Today, hi everyone. Today we will be talking about how to empower your Bedrock agent with a GraphRAG. Sorry for that. And I wanted to start with a quote of Andrew Ng, who is a founder of Deep Learning AI and is a pretty known figure. And he said about knowledge graphs that knowledge graph can improve the context you pass to the LLM and the performance of your RAG applications. And today in my talk, we will be having a look inside why knowledge graph can be beneficial if you already have some experience with a RAG in your applications, and if you want to explore something new and something that can bring you additional insights. So today we will first focus on the reviewing the terminology, because it is quite crazy, because there are a lot of mixtures in the terminology between RAG, GraphRAG, and hybrid RAG, so we are going to have a look inside. Then we will see how to create a GraphRAG powered Bedrock agent, how to bring the possibilities of graphs to your agent, and we will talk briefly if you want to have more customization beyond this point. And my first examples would be around tourism, but maybe it's not a very popular domain. If you want to explore different domains, I will also provide you examples of different industries where this can be beneficial. And we will talk about what things to keep in mind when you're working with a GraphRAG and Bedrock agents. And we will have, if we have time, Q&A. So my name is Darya, and I work as a senior data scientist, and I'm also an AWS Community Builder. It's been already almost 3 years in a machine learning category. I love learning new stuff about AI, Gen AI, NLP, machine learning, and I love to share my knowledge with others. So first, let's talk about terminology. Yeah, it can be easy to get lost between RAG, GraphRAG, graphs. So let's first talk about traditional RAG. How many of you have heard about RAG? All right, perfect. How many of you touched RAG, have some experience with it? Great, great. So I will keep the traditional vector RAG part briefly. Why we need it? Because a large language model's context size is limited, and if we want to bring additional knowledge to our large language model, we need to manage to pass this information to our model. So if we have a collection of documents, we are chunking them, dividing it into pieces. Then we vectorize these pieces, store them in a vector database, and then if we query, if we ask a question to our model, it will go to the vector. So we will go to the vector database and perform a similarity search and retrieve top relevant chunks, and then pass this as a context to our large language model, so it can be aware of what's inside, and it will figure out how to create a meaningful answer to us. But I mentioned top N of chunks, and yeah, this is where it comes to a sort of limitation, because what should be top N be? Should it be like 20 pieces or 10 pieces or 5 or 3? It's hard to know upfront. Also, large language models are not great in a certain type of questions where you need to understand relationships. For example, consider this question: which cities have direct flights from Chicago or from Milano to that and offer popular seafood restaurants? So we can break down this question into like 2 questions. what cities do have direct flights from Chicago, and what are popular seafood restaurants in those cities. And if we have a collection of documents, let's think about, let me go there. So imagine that you have like a bunch of different documents, and some of them mentioning some flights from Chicago. Yeah, it's mainly like unstructured data, and some of them are mentioned some restaurants in other cities. So if we have, like, imagine that you have top three chunks retrieved, you can easily overlook some of those relationships. So what if we had some kind of structure where we can understand and connect those entities to each other? Like here, we have Chicago, it has flights to Honolulu, has flights to Cancun, and we have some restaurants located in those cities. And that leads us to a knowledge graph. So this graph is constructed from explicitly linked entities and relationships from our data. And they're usually stored in a graph database or a triplet store. So like the basic piece of our knowledge graph is a graph triplet. It's a subject, predicate, and object. For example, like Milan, it will be a subject. Located in, it would be a predicate. Italy, that would be an object. And by combining all these triplets together, we can obtain a complete and complex knowledge graph. So, and in that case, what is a GraphRAG, if we think about it? So this would be a RAG methodology that incorporates a knowledge graph as a part of the retrieval process. So you can think about that we would query this graph and return some parts of this graph and pass them to the model. If we go to our example with Chicago and different cities, we would have to retrieve those triplets based on our query. We will extract them from our graph, and we will embed or encode them. We will pass them in the context to our large language model, and it will produce a meaningful answer, like summarize the information it has. And if we want to create a knowledge graph, so the previous step was assuming that we already have some kind of graph, but how to get it, right? So the creation of knowledge graph nowadays is much more simplified comparing to the days we didn't have any like large language models. So we can use a large language model to first pre-process our data, to clean it up, and then second step, to extract those triplets, those basic relationships inside the graph, and then pack it and form a complete graph. So this process is not like so straightforward. There are a lot of like check-ins and I would say resolving of different entities included, but now it's much easier than without large language model. But actually, let me go back. So once again, if we want to compare traditional vector RAG and a graph RAG, I love the analogy of a big library. And if you want to search inside this library, traditional vector RAG would be like having a search system. Yeah, you have your query, and it just shows you the books that are relevant to your query. But having a GraphRAG, it's like having a smart librarian who understands the relationship between books, though it may be not so obvious. But in reality, you don't need to choose one or another, because you can actually combine the best of those two worlds. So you can query, like you can use traditional vector RAG, and you can leverage GraphRAG additionally to unify context for large language model. And now we're happy because models are getting like bigger and bigger, and they can handle a rather big context size. So it can combine both best of two worlds and balance high quality answers with comprehensive context retrieval. So, and I'm not just like saying it out of my head. There are some research papers and some companies like Latria. They conducted research of comparing those approaches. Don't let this GraphRAG by Latria deceive you. This is actually a hybrid RAG approach. So what they did, they compare traditional vector RAG performance with hybrid or enhanced approach with a GraphRAG. And you can see that if we focus on correct answers percentage, it would be like 57.5 versus 80 versus almost like 82%. But if we combine correct and acceptable answers, then it would be like 70 versus 90, more or less. And they used, let me think, they used a combined data set with finance, law, industry questions. So I consider that a rather good benchmark. So when we are done with all this terminology, let's talk how to create a GraphRAG or like GraphRAG enhanced Bedrock agent. Thanks to recent reInvent announcement, we can now do it like with a no-code setup automatically when we are creating a knowledge base for our Bedrock agent. And what it does, you can even go to the console and create a knowledge base powered by a GraphRAG, and it will create an Amazon Neptune Analytics graph out of your unstructured data. And you can connect this knowledge base to the agent so it can use it to answer your questions. And let's go quickly over the steps you will perform. So first step, you will create the agent itself. Every time I'm talking about creating the agent, every time I have to change my slides because the setup is changing so rapidly. So, and this time was no exception. Okay, you go to Bedrock console, you choose Builder Tools, an agent, and then you create agent. You will provide the name and optional description. And here is the surprise. Yet now you don't need to provide any instructions for agent. Why it is a surprise? Previously, it was highly recommended to provide instructions, so you set up a role, how your agent should act. But now, you just, if you assume that you will be just using one knowledge base, and this is everything your agent should do, you can skip instructions. So this is a new part. And then after you're done with your agent, it's just like a couple of clicks, then you can create a knowledge base. Again, we will be using Bedrock. Go to console, choose Builder Tools, Knowledge Bases, and create knowledge base with vector store. And then you need to provide some additional details. Every time I was using Amazon S3 as my data source, but there are multiple options. And then you need to specify the details of your data source, like provide the data source location, S3 URI, and also passing strategy. Most probably you would have to use a default strategy, but if your data has a lot of pictures, I would recommend, and you want to use this information, I would recommend to use foundation model as a passer. Also, chunking strategy. In most cases, you can fall back to default one, but for example, if you need to pass chunk your data like in a specific way, you have a specific use case. For example, you want to chunk your data by chapters or articles or something, then you will need to go beyond default chunking. Yeah, then you would use the embedding model. Just make sure you have access to it because it doesn't check it automatically, at least for now. I don't know what happened tomorrow. And then you would need to choose Amazon Neptune Analytics GraphRAG as a vector database. Then you review and create your knowledge base, and then make sure your data sources are synchronized, synced. And then you can select a model and test. It's always a good idea to test your knowledge base, and I will show you why. And by the way, you may test it in like two ways. You can use a model to generate responses, or you just can test what kind of chunks are retrieved based on your query. And if you want to connect like the last piece of the puzzle, you will go back to the agent. You will go to agent builder, knowledge bases, and add your knowledge base. And be cautious because currently there are like maximum of 2 associated knowledge bases per agent. But in our case, we have only 1 knowledge base. And then you can test your Bedrock agent there. Yeah, it all sounds so easy. You just go there, click there, connect, upload. And yeah, there are some kind of errors that can possibly, like everything possibly can go wrong. I will not deceive you. Yeah, but some popular mistakes is, the first one is to check whether your data sources are synced. Because if they are not, for example, your PDF cannot be parsed. And you will see just a tiny little warning that something is not wrong. You can like, okay, you can skip it or ignore it, but this data won't be used, won't be regarded by your knowledge base or by your agent. And also, in my case, I was wondering why when they introduced GraphRAG, why they're talking about unstructured data. And I tried to use some kind of structured data. I tried to use CSV files, and don't do this. Honestly, even the advanced chunking doesn't help, because if we just chunk like 1 row per chunk, it will be like too small piece of information. And if we supply everything like 1 CSV file, it will most probably, if it's not big enough, it will most probably be like a single chunk. And yeah, you can imagine that providing a 1 table as a chunk will just mess it up everything, because it will be able to find all the entities inside this table. And check the agent responses. Yeah, because in my example, when I was trying to find good seafood restaurants with direct flights from Chicago, from New York, you will see that here I had a like hotel placed in a wrong city. So based on the agent response, it was in Cancun, Mexico, and it even had a link to source chunk number 1. But if we go and explore this source chunk, we will see that this hotel was at Honolulu. So, surprise. And yeah, also referring back to the first part where we were reviewing the terminology, what kind of RAG is that? Why AWS introduced it as a GraphRAG? Like in reality, it's a combined approach. It's still a vector-based semantic search plus structured graph traversal. Because I don't think that there is one possible use case where you would like to use the GraphRAG itself rather than combining them. So this hybrid approach will enable both precise matching and contextual exploration. If we try to stick to this automatic approach. It will create the Neptune Analytics graph automatically, but if you want to look inside the graph, if you go to your AWS Management Console, you cannot just do it like click on it and explore it. You will need to have some additional solution to do it. And happily Neptune provides this. You can create a notebook instance, and you can use Jupyter Notebook, and in our case only open Cypher query language to see what's inside your graph. And yeah, you can use like this query language, open Cypher, or you can use some sort of magical commands like here, summary, and you will understand what's inside your graph, at least overall, or at least like by querying specific pieces of it. And also, if you create a Jupyter Notebook, you can open Graph Explorer. There is also such an option, and you can like touch and see what's inside, what was created on your behalf. And yeah, I actually have, let me see, we have time. I actually have a short video. Let me show it to you. Yeah, this is my data. Okay, so the first one, if we want to search the node, we can do, we can choose the node label. In our case, it was entity. Cancun is a city, and we can explore which chunks are mentioned in Cancun. And you can see the chunk like text, and you can see its location and what document it was found. And I was going like round and round and exploring, and actually all these chunks have Cancun as a city mentioned. And then we can also expand those chunks, and we will see what other entities are mentioned inside them, and we can explore relationships. So you can see in the middle I have a chunk with the flights from Los Angeles, and I have different entities mentioned inside these chunks. So I have American Airlines, I have another kind of airlines, I have Los Angeles here, I have Honolulu, and I just decided to expand Honolulu. You can drag and drop, just arrange as you like it. And what is interesting here is that also the sort of connection between entities, you will see that also we have a direct flight from New York to Honolulu. This is Honolulu. But actually they are connected through the document, through the chunk of the document. So there is no like direct connection between two entities just by this document chunk. So this was an interesting insight for me, because I didn't expect that it would be built in such way. So if this approach, like automatic, no-code approach, is good if you just want to explore, is it relevant for your use case? But if you, in case you need more customization, just prepare to be to be more hands-on and to work more with code and to go through long hard way with the GraphRAG toolkit. Why is it so? Because it was announced and released in January, I believe. And I believe there is still a lot of work that should be done. So what is GraphRAG toolkit? First of all, it's an open source Python library that makes it, I wouldn't say straightforward, but easier to build graph-enhanced RAG workflows. And first of all, you may want to use it to automate the creation of graph with vector embeddings, with creation of graph, and vector embeddings from unstructured data. So first thing you need to do is to create vector store and a graph store. And in that case, this toolkit will help you to create a network or Neptune database cluster with for example, serverless instance, and also an open search serverless collection or index. And then if you want to query the open search serverless index and Neptune database, you may want to wrap it. And actually we have a more complicated approach than just to create a knowledge base. And you can see that we don't have any knowledge base here, right? It's because we need to build it by ourselves, not from completely scratch, but okay, we have open search serverless index with our vectors, we have our Neptune database with our graph, and we need to query them using GraphRAG toolkit. It will use Llama index. It will pass what is retrieved as a context to a large language model, probably Bedrock model, some of the models. And all this code should be contained inside Lambda function, and it should be wrapped as an API, so your Bedrock agent can call it as a tool out of an action group. So this approach is still new, is still, I would say, raw, but this is just if you need much more customization. If you're not happy with the default graph, create it, or if you're not happy with the strategy, how the information is retrieved from the graph. And you saw some examples based on tourism, but let's think about what kind of data, what kind of industries can benefit from graph information. Best of all, it would work for some unstructured but still connected data, where you have a lot of, I would say, messy documents, and here and there some items can be mentioned multiple times, which is, I guess, it's an example of company policies, some kind of internal documentation, legal documents. Also, if you have a long history with some companies, why not? Also medical documents, and this example was taken from the Neptune Demos website. You can see some medical diseases connected to each other. And also I saw an interesting paper about market analysis. So you can leverage information from news, for example, which company acquired which company, and what kind of outcomes it may have to the market. And let's talk about what important things we need to keep in mind when working with a GraphRAG. So, as I mentioned, data type is important. Unstructured data is the best for this case. Also, graph quality is important. I would encourage to go and check what was built automatically, or even better, if you need more control, build your own graph or bring your own graph if you have one. Also, testing. It's never too much of testing. And a price. You can see if we would use an automatic creation of knowledge base with a GraphRAG, the smallest analytics graph would take you $50 per hour. Maybe it's not the case that you would like to have it all the time. And yeah, you can see that I was paying nothing out of my pocket because I was happy enough to have AWS credits in that case. And yeah, this brings us to some recaps or takeaways. First of all, hybrid RAG. We talked about traditional vector RAG, we talked about GraphRAG itself, but in reality, we would like to focus on something like hybrid RAG, which combine strong sides of two words. And if you want to experiment with them, start from automatic graph creation with Bedrock knowledge bases and try to experiment with GraphRAG toolkit if you need more customization. And the best case is to use GraphRAG for unstructured data in some complex domain with intricate relationships. I would be happy if you provide your feedback. And I don't know, what time is it? Whether we have time for questions.
Yes, sure.
Thank you.
That was a fantastic session. Thank you. I'm sure that you have a lot of questions. Who wanted to? Please raise an hand. Okay, perfect.
Hi, first, great talk.
Thank you.
You mentioned about using unstructured data for this GraphRAG. Are there any guidelines on how to write this kind of documents and data for optimize the job of the knowledge base?
You mean the guidelines when we want to build an automatic knowledge base, right?
Yeah. The documents you feeding for it to put into.
I haven't seen any guidelines on that, and unfortunately, the documentation is limited. Yeah. But what I can tell from my experience is to try to have like more unstructured data than structured data, no tables, and also check if you provide in PDFs, check its quality, whether it can be parsed, because if it cannot be parsed, it will just be skipped and you will be missing out this information. And also, I would say that would be nice if you have some noise in your documents, maybe to go to have the initial round of feeding these documents for some kind of large language model to clean it up and then to store it for creating a knowledge base.
All right, thank you very much.
Thank you.
Okay.
Thank you. I love the talk.
Thank you.
You mentioned that this approach is raw and new. So I'd be interested to understand what's your opinion about how, or your recommendation about how they might improve the experience going forward to make this easier for people?
Yeah, it's a great question. I would say that, first of all, I would rather put additional efforts on this GraphRAG toolkit, because now I know it's quite fresh. It was released like 2 months ago in January, and it's still not comprehensive to just start using it. And also, I noticed the lack of tutorials, like end-to-end tutorials. Sometimes they're just starting, okay, imagine that you have already your knowledge graph and what we will do to query it. So I would rather make a focus on people who want to code and to have a little bit more control over the process. Thank you.
I didn't fully understand the part how the data comes into the graph storage. So from what I've seen, there is a two-stage process. One is using an LLM to get the unstructured data and extract from it like the relationships. And the second LLM that inserts like the relationship into Neptune. Is this, and what models did you use? Or
yeah, let me go back to these slides, because it was, let me go back. I guess you mean this part, right?
Yeah.
Yeah. So this part was not about what is happening when we automatically create a knowledge base with a Bedrock. This part, it was actually like stolen from one paper, and they did this on their own. So they explains the process of how they approach the knowledge graph creation. They had LLM to clean the data and then had LLM to extract those entities. I wish I would a sneak peek to see what is going on under the hood when we are creating this automatic graph with Bedrock knowledge base, but I don't have a possibility as a user. I can see only like the end result and I can query it, but it's essentially a black box what is going on there.
And my second question is, in
Yeah.
Neptune, like the graph that was generated had a specific format. It has those chunks that were sitting between the relationships. So if, for example, I have my Neptune database, my own one, where I insert my data, for example, friends and like my own schema, will that work as a knowledge base, having like a different format without having those chunks and so? Can I hook that?
I believe you cannot bring it as a knowledge base to Bedrock as this like part of automatic process. But what you can do is to use a GraphRAG toolkit. So you have already like graph created, and you can use GraphRAG toolkit to write custom logic of retrieval and form Rapid as an action group tool. Currently, it's like this, unfortunately.
Okay, thank you.
Thank you. I see a question
Okay.
here.
Yes.
Thank you for the talk.
Thank you.
I have two questions. The first one is, in the Neptune database, we need to store also the embeddings, and the second one is, when there is the graph traversal to, I imagine that there is an entry point with the RAG, with the vector similarity to find an entity, and then there is the graph traversal to retrieve the context. When we need to stop the traversal of the graph, there are some guidelines, because I know also that LLMs, when the context is too long, have the recency bias, so they focus more on the start and the end of the prompt, the context. So if I imagine the context becomes too large, it can raise problems.
Yeah, it's a great question. Thanks for it. And yeah, the issue is you cannot. You're just out of control of what's happening, how the traversal, you explained the process pretty well. So first it enters the graph using the embeddings or some search terms, and then it does the traversal. But as a user, I don't have much control. I can control like parameters of my LLM, which is it's not how long the graph would be traversed, or I can break down the query to multiple queries if my query is complex. But I haven't seen any parameter which controls the traversal length so far. Thank you.
Thank you.
Thank you. Thank you so much.